ايه هلا مش الحال.
Okay. Okay, great. So, does anybody have any question before starting to solve the problem? حدا عنده شي سؤال على الشابتر؟
لا.
طيب. Okay, so وصلتكم لكن الاكسرسايز البروبلمز اللي بعت لكم اياهم.
صح.
I will share it. Okay, I will share it. Okay. So problem 1 هلا بالبروبلم 1 كان في بعتقد هون y of 0 equal 1 هيدي ما شو هيدي شيلوها. Okay, this is wrong. هذا الغلط. So consider the following equation: x multiplied by 1 plus x minus exponential of x equals 0. So we show that this equation admits a unique solution on the interval 0, 1. Okay, so basically يعني على 0 على 1 to see whether we have f of and الو عم تسمعوني؟
ايه هلا
ايه سامعين.
عم تسمعون؟ اوكي. ما بعرف شو صار على الانترنت. اوكي. So share the screen now. Wait. Okay, so we have that f of x in this case is equal to x multiplied by 1 plus exponential of x minus exponential of x. Okay, so in order to show that this function admits is a root somewhere in the interval 0, 1, so first we study the derivative to see how the derivative behaves. So this would be 1 plus ex plus x ex minus ex. Okay, so this would give 1 plus x ex. Okay, so this is positive on the interval 0, 1. عم تقشعوا؟ كله تمام؟
ايه
عم تقشعوا؟ Yeah, okay.
ايه سامعين.
Okay. So now we have to study the f of 0. Okay. So f of 0 in this case is equal minus 1. And 0 multiplied, this is 0. Okay. And f of 1 in this case is
1.
Yeah. يعني يا ريت بعرف كيف بيعملوا automatically بفوتوا. It's an option somewhere but I don't know how to do it. I didn't find Okay. Okay. So let's see. So we are solving the problem of the problem set that I send you. Okay. So first we are checking if a solution exists level 01. Okay. We're studying the derivative and we're studying the function on the 01. So f of 1 in this case is 1 multiplied by 1 plus e minus e.
1
is 1 multiplied by 2 plus e. So it's 1. Okay? So basically your function, so you have that f of, so this is f prime is positive, f is 1 is increasing, it's going from -1 to 1, and you have a 0 here somewhere. Okay, so a unique solution is this interval because it's monotonic. Okay, it's constantly increasing, and f of 0, f of 1 is negative. Okay, نقلتوها فينا نمحي؟
المفروض ايه.
Alright.
الدكتور ما حتعطينا الكوركشن خالص انه محطوطه خالصه؟
عم بعملها هلا لايف.
إنه-
اعطينا اكسرسايز اذا بدكم بعطيكم اياها خلصه، بس انه عم نعملها لايف يعني بنقلوها.
انه بعدني واصل انا صراحه ما لحقت بس هيك.
اصحابك يعني. Okay. Okay. Now find the fixed point iteration and study its conversion. So the fixed point iteration, so we have to convert from x equal g of x. Okay. So this was our initial problem here. x1 ex minus ex, okay, equals 0. So the simplest fixed point iteration is to choose to make x plus x ex minus ex equals 0. Then x is equal to ex
minus x
ex. Okay. Yes. So g of x here is ex minus ex. Okay.
Okay.
Okay. So now we have to study the derivative g prime of x conditions.
Okay.
Now for the fixed point, which are the contraction and the inclusion. Contraction. One way to test the contraction is to test that the absolute value of g prime of x is inferior to 1. Okay. So yes, let's study now the g prime of x. This is exponential x minus exponential x, okay, minus x exponential x. Okay, so basically, okay, this is equal to minus x exponential x. Now, so the absolute value of g prime of x is equal to x exponential x. Okay. Now this is not always inferior to 1 on the interval 0, 1. For example, g prime of 1, okay,
is
equal to e, which is superior to 1.
True.
So prime of x is in general not all the time inferior to 1. Okay. So this this choice of fixed point iteration may not converge. Okay, so we have to find another fixed point iteration.
Okay.
All right. So G prime is not always infinity to 1, so this may not converge. Okay, so we have to find another one. So another choice, I will erase now. You can, did you finish?
Yes.
Yeah.
I guess.
Now another choice would be to use x over 1 plus ex, right? So shift the x on
Okay.
x is equal to ex.
Mhm.
Okay, so this is another possible fixed point iteration. So g of x is equal to ex 1 plus ex. Okay, now let's study the g prime of x here. Okay. So the g prime of x in this case is so it's uv minus uv prime divided by v squared. Okay. So this would give me, so 2x minus 2x. So I have ex divided by 1 plus ex squared.
Mhm.
Okay. So now you see that this is in absolute value inferior to 1.
True.
Okay. So g of x is a contraction. So this is verified here. So now we have to test the inclusion.
Mm.
I will personally now, so I can delete it. Okay, so now the inclusion, I have to test g of x on تسمعوني؟ شكله الانترنت is not stable. So g of 0.
كتير عم بيعلق.
So g of 0 is 1. This is the internet in Lebanon. شو فيها أعمل يعني. Okay, so it's g of 0 is 1 over 1 plus 1. G of 0 is 1. So this is equal to 1/2. And g of 1 is equal e over 1 plus e. Okay, so this is also inferior to 1. Okay, so this is also between 0 and 1. Okay, so because g of x is increasing, the maximum value of g of x, okay, is this value here. So g of x is, okay, included in the interval 0, 1 here. Okay.
Okay.
So this is the inclusion condition is satisfied. So this choice of g of x should converge towards, if you
The solution.
if you take any x0 belonging to 0, 1, okay, for example 0, 5 or 0, 2, and then you make xn plus 1 is equal to g of xn, and x1 is equal to g of x0, extra x2 equal g of x1. Now this at the end, to a
Will
certain number
convert
of
to the solution.
you get closer and closer to the solution.
Okay.
If each are satisfied, then this should converge towards the solution.
Mhm.
Now let's study now the Newton method.
بس دكتور فينا اقترح شيء؟
Okay.
بس معقول فيك شو الطف الكام يلي عندك مش السكرين شيرينج الكام بس كرمال بركي بتسرع نتفة ببطل يعلق الصوت.
I will wait.
ميرسي عم عزبك.
Okay. So now let's study the Newton. So the Newton is a fixed point iteration, as we said in the lecture, but in this case, x is equal to x minus f of x over
F prime of x.
So in this case, is equal to x minus f of x gain it x1 ex minus ex over f prime. We calculated the f prime was 1 plus x ex. Okay, so this is the g prime. I showed in the lecture that when x or xn is close to s, okay,
Mhm. F of x0 times f double prime of x0 is positive.
is close to s, okay, so we can develop the error en plus 1, okay, would be g prime
1/2
of s en plus, okay, 1/2 g second of s, okay, g second of s en squared, okay, and I showed that this one is 0, okay, so you are left with this, okay,
Yes.
g second, and the g second, I gave the expression for the g second here. So the g second is f prime over f second of s, I think. Okay, that was correct, no? F prime over f second. Maybe you can derive it. You can even take the g prime of this, derive it to get the expression, and derive it 2 times to get this expression. So it's f prime over f second. Okay, I'll just verify. It's not.
I think it's f second over f prime.
Yeah, I have to verify it.
Okay.
Just like. I will send you the presentation that I used also. I will send it to you by email.
Okay.
So you can study on the presentation. So it's f second over f prime. Yes, you're right. F second over f prime. Okay, so f second, okay, is, so this is f prime, and f second would be ex okay, plus xex divided by 1 plus xex. Okay, so okay, so we have to see if now this quantity must be inferior to 2 in order that we have quadratic convergence here. Okay? An plus 1 must be inferior to en square. Okay, inferior or equal to en square. Now let's see if we can show this. So I don't know if we can show it in this case that it's quadratic. So it's ex. I'm not sure we can show it here. That it's quadratic. Yeah, I'm not sure that we can show in this case that it's quadratic if we don't know the solution in this case. Okay, I'm not sure that we can show that this is inferior to 1. Okay, for this case, I must see, but I don't think so. Okay. Yeah, I don't think that we can show it here in this case because this is not necessarily inferior to 1 because if you take
No, it's not.
yeah, it's not necessary. So, but we have to know what is the solution. But the solution we can only obtain it numerically. Okay. Now, for the solution, this would be inferior to f. Now, another thing. Okay, so another thing that you must. So the quadratic convergence is not sure 100% that we have it. Okay. Now another thing that we must see is that if we want to choose a point x0 for the fixed point iteration, okay, we have to verify that f of x0, f seconds of x0 must be positive. Okay, so this is one condition that we must verify. So the f second, as I said here, is the f second of x is ex plus xex. So this is positive. Okay. So we have to choose, okay, x0 such as f of x0 is positive.
Positive.
Okay. Because the f second is positive here. The f second was negative. Okay, we should have chose x0 such
negative.
as f x0 is negative. So these are the that we must verify in the Newton, and the Newton is also being a fixed point iteration also prime of x must be inferior to 1, that it converge if it's far away from the solution. Now, if it's close enough to the solution, okay, it will converge normally. It will converge in any case because the G prime will be around 0, so it will converge. But if we are far away from the solution, we must check also that the G prime of x is inferior to 1 also, because it's a fixed point iteration. Okay, so these are the conditions that we must we can verify. We can verify the quadratic convergence close to the solution. We can verify the convergence when we are far away from the solution, if this is inferior to 1. And if we want to choose a initial point, so we must choose f of x0, f second of x0 positive. So we are sure of the convergence of the Newton. The Newton method, normally if it's close to the solution, it converges very fast, and this you can verify it in the program. Okay. For the second problem, try to do it at home, and I will send you the correction. The second problem, okay. But problem 2, I will give you just a hint, because I want you that, okay, you practice on these things so that you solve the problem. The fixed point iteration, okay, so you choose if you take the simplest fixed point iteration here, okay, we will probably gain log 1 plus ex minus equals 1 minus x. So if I take x is equal to 1 minus log of 1 plus ex, okay, so my g of x is this 1 minus log of 1 plus ex. Now I think here it will be a contraction. Okay, you can verify that it will be a contraction, but the inclusion will not be satisfied. Okay. So in order to ensure the inclusion, you have to use the middle third theorem. Okay, you will have to extend your interval 0, 1, and instead of using 0, 1, you will have to use minus 1, 1, minus 1, 2.
2.
Okay. And if it's still a contraction inside of the interval minus 1, 2, then you will have
inclusion
inside of the interval minus 1, 0, 1, you will have inclusion in the larger interval and convergence of the algorithm. Okay. So هعطيكم تعملوا هذا at home, and كمان للنيوتن you can check the three conditions. Okay, if it's the convergence near to the, I mean the quadratic convergence, the absolute value تبع g prime of x شو اسمه initial point, okay, f of x0, f second of x0. So all right, so I will send you the question. اوكي بس انتم جربوا بعتكم اياهم هاليومين يعني الكوركشن، انتم جربوا عملوها لوحدكم وبعتكم. Okay, and you have till Monday to the task. It's Newton Newton program is not complicated, very simple. You should be able to do it fixed point iteration. This is very simple to program. استعملوا الفلو شارت وكذا. هلا التحدي شوي بالسيكنس، بس بالسيكنس مش هالقد كمان صعبة يعني، بس إنه بديكم تفكروا فيها شو.
دكتور وصل لك
بس
شيء الميل تبعك؟
you should be able امتين بعده؟
بعته التنين بعتقد.
Okay, you solve the problem
Yes.
على مطلب أو شو؟ ما
لا
لا.
مطلب بعت لك
Okay,
اياهم اتاكس.
okay, I will look at it.
اوكي.
Okay. So this is for now. Okay, next week we'll start a new chapter. Okay, ببعثكم إياها يعني maybe one day you have it. Okay, it's about polynomial interpolation. And if you have any question concerning this chapter, you can ask me in the next session, and that we will do Monday. We will do a session على 9:30 أو على غير وقت مثل ما بدكم يعني. بس لأنه على 9:30 نحن كان عندنا سيشن، بس إنه we'll make a session وراح أصلح البروجرامات يعني. So كمان نص ساعة هيك بصلح البروجرامات. So إذا بتفضلوا غير وقت ما في مشكلة. So قولوا لي يعني.
Okay.
طيب, have a nice day and
You too.
see you soon.
Thank you.
Okay.
Bye.
Take care.
باي.
Bye.